Hello everyone, welcome back to another episode of Advent of Code 2021 in C. Today with part 2 of day 1, since the last episode was way too long, I didn't put it in there. But in this one, we're gonna see we have a part 2 and we're gonna go through that and solve that. So I've already prepared that we put our old solution in the part 1 function and we're gonna have a new function called part 2. And we're just going to see what happens. So let's read this. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Okay, start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A, their sum is that. Second window is marked B, their sum is that. The sum of measurements in the second window is larger than the sum of the first. So this first comparison increased. This seems very difficult to do in C. Like, non-shittily do in C. So there are multiple ways we could solve this. The first way we could solve this is to keep like a modulo. Keep probably 3 arrays around. Fill them with the data as 3 sums, 3 running sums, right? 2 or 3 of them, and then depending on whether we're on a first, second, or third one, we pick one of them and stuff like that. That's awfully difficult. The other option is we could put all integers that we have in an array and let's see okay, so the puzzle input hasn't changed, so it is just the numbers. This isn't part of the puzzle. It would be like different kind of puzzle. So we could just put all these integers into a large array and then literally go over 1, 2, 3, go back 2, 1, 2, 3, figure out the difference, you know, something like that. Like keep a last sum, that's the sum of these, and the current sum of these, and yeah, I think that's a better option. Another option is obviously to just go straight in the file and like there's definitely some smart way to do this. Since, you know, technically with A and B, we're only comparing this and this number because these are the same. They just cancel out. And then for the second one, we compare this and this number, which are in this case the same. No change. So yeah, maybe the sliding window thing is actually kind of easy because we only have to look at the first number and the fourth number, and the second and the fifth, and compare those, right? Because there's no... That's it, right? That's it. That's easy. So the first and the fourth, so first plus 3, second plus 3, third plus 3. So, am I dumb? Does that work? It still means we have to put it all in an array, right? But that makes it significantly easier. Okay, so let's get rid of this previous thing. We don't need the previous thing or the logic count or any of this right now. This is bullshit anyways. And for now, we just want a while loop. Well, actually, we want a for loop, don't we? Let's do a while loop. Who cares? Let's do a for loop. I'm sorry, I can't decide. Char C is buffer. Well, actually, char pointer P is buffer P. P. There we go. I'm saying way too many P's. It's gonna end well. Okay. And so if P is a new line, we increase new lines. Okay, so this counts the new lines, right? So the next part we need to do is to parse all of them. Well, let's first allocate a buffer. So we want a size t buffer, int buffer, or let's call it like a value buffer. Values, let's call it that. Size t times new lines, and we know the last line isn't empty, so it doesn't matter. And we actually want to free that, of course. Whoops, what did I do? Okay. Now, whoops, sorry, pointer. So value size, that's the value size. I like this pattern a lot. Okay, so now, for size t I equals 0, I is less than values. Well, actually, we wanna chill out. Well, okay, so this is getting very confusing. So we want to do this, string to L, and then literally just say values size ti equals 0, values of I is value, and then we increase I, and that's it. Okay, so now we have, what is this saying? Allocation size of 0. No, it doesn't. No, it doesn't. What is it doing? Why is it saying that? That's stupid. Okay, whatever. Well, it's actually not null terminated, is it? Yeah, so we need to do a different thing. I'm done. Okay. So size ti, well, yeah, whatever. I is less than buffer size. That's what we need to do, and then this becomes buffer I. Okay, it says malloc is 0, but it doesn't really know because this is getting changed. Whatever. And right, so now we get. Okay, I'm actually curious. That does make a difference in the weird. It could be 0. It's not gonna be though. Just want it to shut up, you know. Okay. So, so now that we have everything in our values buffer, we can actually iterate over it, right? So for I equals 0, I is less than value size plus I, we can go over it and we can say, so the, well, like I plus 4 needs to be inside value size really, or what is it, plus 3? Yeah, plus 3. So this needs to be within value size, otherwise we discard them. It says this somewhere. Stop when there aren't enough measurements left to create a new 3 measurement sum. So yeah, so I plus 3, if that's still within value size, we can do this. Pretty simple. So size previous, or let's call this first, second. Okay, so the first is values I, the second, well, we don't even have to do that. So size t larger, count 0. So if values I plus 3 is bigger than values I, larger count plus equals values I. Right now it's plus 1. It's plus 1. Okay. So that's garbage value. Index array index out of bounds. Array index out of bounds. No, it's not out of bounds. I'm not dumb. It's not out of, is it like crazy today? Like that's not how this works. It's not out of bounds. What the fuck are you saying? That's so cringe. Could mem set this to 0, sure, but I don't see the point, to be honest with you. Oh, it's because value size is this. Yeah, this is really what we want. Okay. Yeah, I'm a little bit slow today. Okay, so mem set this to 0 just so it shuts up, but this is actually a really dumb mistake. I'm really glad I caught that. Okay, so value size now works, and so if this one is bigger than this one, we increased. Now comes the important part. Now we go to this one, check if this one's bigger than. Okay, so let's see if that works. I mean, that might just work, right? Printf part 2 lu larger count. Still recording? Epic. Okay. Part 2 says 0. Well, I doubt it somehow, but okay. Wait, 0, 1, 2, 3. Yeah. Am I dumb? That plus that plus that. And that plus that plus that. Like, am I dumb? Is this wrong? Did I just make a fool of myself really bad? Like, 199 plus 200 plus 208. And then we have 200 plus 208 plus 210. Then we do 618 minus 607. We get 11. That's as if it's the same difference. It's the same difference as between 210 and 199. Like, I'm right. So why is it not working? Probably this. Let's see. So the what? $2,000 values? This doesn't seem right. Oh. That's not really what I wanted to test, is it? No, it's not. Sorry about that. It still says 0. Okay, well, let's see about that. So we step through. I want to see values I, and I want to see values I plus 3. That's what I want to see. They're both 0. Well, okay, that's not good. That's supposed to be 0, that's what I can tell you. Just 0 all the way through. Okay, so values 0. Why is value 0? Like, I zero it out, sure. What is new lines in this case? We have 10 new lines, right? So we have 10 values. What is this? Fuck. I'm dumb. I'm a dumbass. I'm actually a dumbass. So what does str2l contain? Okay. Return. Zero is returned. Okay, so if value is 0, break, right? And then we literally just do a fucking infinite loop. Really? This is so scuffed. I hate this so much. Okay, now this tells us 5, which seems about right. Yeah, okay, so that's correct. Now let's get our input. 1103. Woo, yeah, baby. Okay, that's day 1 solved. That was a bit of a clusterfuck, I gotta be honest with you. Gotta be honest with you. I'm not sure if that one's such a great one. The sliding window thing really sucks in C, to be honest. Figuring out that a sliding window means that you can discard 2 of them is, I guess, pretty smart. But making it into a buffer is probably simpler in literally every single language out there, except probably brainfuck and like assembly. So yeah, pretty cool, pretty epic. If you enjoyed that, make sure to leave a like, and if you want to see more, subscribe. And I'm quickly going to commit this. Implement day 1 part 2. All right, and I'll see you guys next time with day 2.